Okay, for today, we're going to be looking at find the value of each trigonometric ratio. Okay, we started talking about this yesterday, right? We talked about ratios. I said ratios a fancy word for fraction. I abbreviated yesterday for trig, but I called it trigonometric ratio. And yesterday, in our lecture from yesterday, I also gave you guys a chart. Remember, sine was opposite over hypotenuse, cosine was adjacent over hypotenuse, tangent was opposite over adjacent, cosecant was hypotenuse over opposite, secant was hypotenuse over adjacent, cotangent was adjacent over opposite. I am using that table again. I will actually use that table for most of Unit 8. So save it. Write it down. If you did not write it down yesterday, do write it down. Save it. We're going to use it for most of Unit 8. Okay, so let's go on the names, right? I have to name the three sides as in hypotenuse, opposite, adjacent. So I look for my 90-degree angle, and the angle farthest away from the 90-degree angle, that's the biggest side. So I'm gonna call this the hypotenuse. I know for yesterday, we had theta. Remember theta looked like a zero with a little line segment in between? We had a theta in one corner, and I used to tell you guys, well, look for theta, and then the side that is farthest away from theta, that's what we call opposite. The one that is close to theta is what we call adjacent. But now I don't see theta here. However, I see tangent of A. Interesting. I see the angle A. So that's basically telling me, look for angle A and put theta at that corner. So I will. I look for corner A, and that's where I'm going to have theta. Right? Yesterday, I got familiarized with theta, so I will continue using theta. So on angle A, I'm going to put theta. Now, if it said tangent of C, then put theta on C. Okay, so now I know where theta is this corner. And then I know farthest away from theta, that's what we call opposite. Close to theta, that's what we call adjacent. And I remember from my table, tangent is opposite over adjacent. So I'm going to go 24 over 18. Now, I know if you type in 24 over 18, it says it's wrong because we have to simplify. Okay, some people might be, let's divide this by 3. 24 can divide it by 3. 18 I can divide it by 3. So that gives me 8 over 6. And then if I type it in, if this was a homework assignment, I type in 8 over 6, still says it's wrong. The reason why, because I can simplify even more. 8 and 6 are both even numbers, so I can divide each by 2. 8 divided by 2 is 4. 6 divided by 2 is 3. Then I still ask myself, can I simplify even more? No, this case I cannot. So that's it. Now, some people might say, do I have to divide by 3 and then divide by 2? Or could I have divided by 6 to begin with? Yeah, if you could have divided by 6, it gets you to the answer a little bit faster. But it doesn't matter how fast you get to the answer. Just get to it. Okay, my answer is 4 over 3. The way I'm going to type this, I'm going to go forward \3. Then let's take a look at question number 6. Let me label the 3 sides. I look for the 90-degree corner, and then farthest away, that's what I call hypotenuse. I should have theta somewhere, so I look at the question, cosine of C. Okay, so at the corner C, that's where I'm going to write my theta. So farthest away from theta, that's what I call the opposite. Close to theta, that's what I call adjacent. Now remember cosine, according to my table, cosine is adjacent over hypotenuse. So I'm gonna go 40 over 41, right? Adjacent over hypotenuse. Can we simplify that even more? No, in this case we cannot. So I'm just gonna write that 40 backslash 41. 40 over 41. Do not include any extra spaces. All together. No extra spaces. All right, let's take a look at number 7. Let me label my 3 sides. Find my 90-degree corner. Boom. The side that is farthest away, that's the hypotenuse. I should have my theta somewhere. This is sine of A. So right here at a corner A, that's where I'm going to put my theta. Farthest away from theta, that's what I call the opposite. Close to theta, that's what I call adjacent. According to my table, sine of A, right? Sine, according to my table, was opposite over hypotenuse. So I'm just going to go 35 over 37. Then simplify if you can. This one we cannot, so that's as low we can go. So I'm gonna go 35 backslash 37. Right, 35 over 37. All right, this is easy. Let's take a look. I have my 90-degree angle. Farthest away from my 90-degree angle, that's the hypotenuse. I should have theta somewhere in there, so I read cosine of z. Okay, so here at the corner z, I'm gonna put my theta there. Farthest away from my theta, that's what I call opposite. Close to theta, that's what I call adjacent. Now remember cosine, because here's asking me for cosine of z. According to my table, I remember cosine was adjacent over hypotenuse. So in this case, I'm gonna go 30 over 34. And then simplify if possible. All right, to begin with, I see my numbers are even, right? 30 and 34 are both even. So even means I can divide it by 2. 30 divided by 2 is 15. 34 divided by 2 is 17. I know 15 can be divided by 3, but not 17. 15 can be divided by 5, but not 17. Okay, so it seems like I cannot simplify more. So I'm going to call this 15 over 17. Notice I typed it in. I'm writing it the way you guys are going to type it. I wrote it as 15 backslash 17. Let me do zoom out so you guys can see what we did today. It's right there.